So children, cathode rays we have seen. Now this is the anode rays. Anode rays are nothing but the photons which are positively charged, and they are produced in this condition. And the canal rays are the name is given to these positively charged particles or the anode rays because they form canal-like structure, and canals are visual see the narrow path. Now we'll see next the important point is the properties of anode rays. So first property children, they travel in a straight line. They travel in a straight line. It is very close to the canal ray. This with the cathode rays. Similarly, some experiment when we keep any obstacle or any object, then the path will be stopped, or we have a shadow. If we keep certain anode rays, they are coming from negative to positive. So if we keep here, just I am erasing here. If we keep here a cross, we keep here a cross. So here there will be the shadow, and on the shadow here there will be the this type of arrangement, and the cross will be there. So this is the shadow. So the formation of shadow at the back indicates that it is having the tendency to move in a straight line. So this is one point. Now second point, it is just they are positive charge, so they will be attracted toward the negative plate. So they are attracted. They are attracted towards negative plate. Negative plate. When we keep, see here, if on any side, upside or downside, here if we place here, let the negative plate, and so what happens? Children, there will be bending of the rays. So rays will again bend toward, there will be bending of the rays. So it is there. Then again they have magnetic character. They have magnetic character. If we put here magnet, then they will bend towards the magnet. So this will indicate that they have magnetic character. Now the contrasting feature, children, contrasting feature, that they do not cause X-rays. They do not produce X-rays. They do not produce X-rays when allowed to fall on heavy metal. So X-rays are not produced. So it is there. And other point, children, the E upon M ratio is not constant. E upon M ratio means charge to mass ratio is not constant. It means the photons are not fundamental particles. Unlike in case of cathode rays you have seen, the E upon M ratio is found to be constant. And that's why we say the electrons are the fundamental particles. We say electrons as fundamental particles, but these are not canal rays. They are not called as fundamental particles because E upon M ratio means charge to mass ratio. It is not same, not constant. It is different for the different gases. And so this is about the very important point of the this canal rays. Now the last portion, children, on the basis of experiments. Here the charge was found to be 1.602 10 to the power minus 19 coulomb. This is the charge. Mass, it is 1.67 10 to the power minus 24 grams. See, the mass is very, very heavy. And so mass is very heavy, and this mass is equal to that of the hydrogen atom. This mass is equal to hydrogen atom. And the E upon m ratio, see, 9.58 to the power 4 coulomb per gram. So it is very high, and so as a result, it is variable. This E upon m ratio, it is for hydrogen and is variable. So this is all about the canal rays or anode rays. Now students, today we will see other particle present in an atom, and it is nothing but it is about the anode ray. Children, so atoms are electrically neutral. Atoms do not have any charge, and so it is due to the presence of equal number of electrons and protons. So anode rays are nothing but they are also called as canal rays. They are also called as canal rays because of some reason you will see in later part. Canal rays, or they are also called as protons. Canal rays or protons. Now they are also produced by the discharge tube, but here the discharge tube is slightly changed, and the discharge tube, just here there is the discharge tube, and similar construction here. There is a slight change here, and again here there is a place for the vacuum here, and at this place there is the anode, and there is a change here, children. See, in this there is the cathode, and the cathode is perforated. This is perforated cathode. Cathode has been taken. Perforated means a small holes are there, just like a sieve. And here, of course, there is a high tension source. It gives around 10,000 to 20,000 volts, and so this is there. This is the suction pump to suck the air, and so here it is the anode. Here there is the cathode, and here the gas is at very low pressure. Again the same condition. Gases are at very low pressure, similar to that of the cathode phase. So here gases at very low pressure. Around it is 10 to the power minus 2 atmosphere. Now children, how these rays are produced. Actually these rays are produced by the ionization of the gas present inside. The gas is ionized. How? See, if there is an atom, so under the high potential, this atom is neutral. So this atom is converted into this plus this electron. So you have seen about the electron, and this A, it is nothing but it is the proton. And as a result, so what happens actually when there is the ionization of the gases inside the discharge tube? This is also discharge tube experiment of some slight modification, as cathode is perforated and this is the anode. Anode is plain, simple anode, and so there is the ionization. So due to ionization, this reaction actually it will take place here. And so if there is the atom, neutral atom, so atom is converted into the positively charged particle plus electron. So what happens? See carefully. As here there is the anode and here there is the cathode. So what happens? See, I am going to draw you. So the electrons will be moving like this. So this blue color indicates the movement of cathode rays. But what happens? the anode rays, just I am using the black color to this, the here the charge is negative, so these particles, A particles will move towards this, and so as a result there will be the, as the light is very faint, and so there will be this, see the canals are appearing here, and as a result these are the canal like appearance, the canals are there, and so they are called as canal rays. Actually they are the canal rays. And how you can see, this is the front portion of the perforated cathode here, and there is the, like this, and so all the particles, they will not pass through the holes, because holes are limited, so some will be able to pass through, and as a result there will be the formation of canal. And so we can represent more, precisely like this. See, I am going to draw here. So see, the canals are here, just I am going to thick it again here. See how I am drawing, again here, again here. So see children, these are nothing but these are the canals, and so their name is originated. And so this is, then we'll see about the properties. So the properties are very close to that of the cathode rays, and we'll see.